Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is NUR FARHANA Binti ZULKOPLI and my matric number is 301199. Today I'm going to explain about our question is ERO, which is we have to make a program about calculation with method ERO. Okay, so first of all, at this first part here, we have to import a scanner class from package java.ot so that we can take input from the user. And then we declare our public class as ERO following our question so that it will be more understand. And then we have one method here, which is a main method. We only use one because it is a simple program. And then scanner here, we want to create a scanner SC so that we can take input from user, which is like this one. Alright, so at this part, we display an output for the welcoming the user here, and we display two choices for them so that they can choose between number 1 and number 2. For number 1, we have 2 by 2 matrix and 3 is 3 by 3 matrix. And then at this part, we declare an initialize variable choose as a choice for the user, which is as example, if the user put the number 1, so it will come at this part. Alright, so for this part, I will explain about the 2 by 2 matrix only because of my other friend will explain about the 3 by 3 matrix, which is following the second case. Alright, move to the next part. We have switch statement here so that we want to make a choice between case 1 and case 2 for the user. Alright, so as I mentioned before, at this part for the welcoming the user, we have two choices. So that means we have two cases. The switch as a variable choose because we put two case 1 and case 2. That means that it follow the choices 1 and 2. So the full coding in the case 1 is all about the calculation about the ERO method for the 2 by 2 matrix only. So for all of this part, it's about we want to prompt user to enter number following the linear equation form that they want to calculate using our ERO calculator. So for this part until this part, it will ask the user to enter number from the linear equation, first linear equation. We will prompt the user to enter number for the second linear equation. Focus on this part, at all this double part, declaration and the initialize of the A, B, answer 1, C, D, and also the last one is answer 2. This A and B are the value of X and Y. Alright, so the answer 1 are declared, which is it means by the answer for the linear equation 1. The next one is for the linear equation 2. We have C, D, and answer 2. So we are going to change the linear equation form become to augmented matrix form. So at this part here, from this part until here, we are going to display the inversion of the linear equation form to the augmented matrix form. Alright, so at this part, user can know the difference between the linear equation and augmented matrix. So for this part, following our format of the ERO method, first of all, we are going to change the number on A to become the leading number, which is number 1. Which is we have to make the number in A and also in D to become number 1. And number in C and B will become 0. And the final result, we are going to get the A, B, C, D are in the identity matrix. So, okay, if our A is not equal by 1, it will do the formula like this, which is B equal to B divided by A. Alright? At this part, it will just change the number in the row 1 only. Divided by A, and also divided by A, following as the A here that we want to change it to 1. Alright? After we do the calculation, we are going to print the output here to show the user that we want to print the output after the calculation. At this part, we have if statement here, so which is same like before. I'm not gonna to explain again. Following the formula, same like before, which is we use the formula C minus by the multiplication C with A so that we can get 0 value for C. And this means automatically for the value D and also answer 2 will following the formula in C. And then at this part, we are going to display or print the output for the user so they can know the changes process here that will be different as before here. At this part, we have also same like before, the if statement for D not equal to 1. So that if the number is not equal to 1, we are going to do the same formula right here. Okay, so I showed it to this part. This part is going to print the output that the user will know the difference between output from here and here. The difference is the answer in here. If statement for the B not equal to 0, which is if the value that user input are not equal to 0, we have to do the calculation to make it become 0. So that as a formula before, it will change to 0 using this formula. And then we print the output here, which means the value that will be changed from this part to this part is B and answer 1. So, as we can imagine here, this part and this part will going to be number 1 and C and B will going to be 0. And then the answer 1 and answer 2 will going to be constant number. So, we have got our identity matrix, right? So for this part, this is the final result of the display output. So that's that. Thank you.
So let's move on to case 2. Well, case 2 is for 3 by 3 matrix. And the first line, 99, which we prompt user to enter the number for row 1 and column 1. And then we store the number in variable E. And then it goes the same for B and C, which for row 1, column 2, and column 3, respectively. And then we prompt user to enter the constant number for row 1, and then we store the number in answer 1. And then we move to the next line, which is 111. We prompt user to enter the number for row 2, column 1, column 2, and column 3 in D, E, and F, respectively, in the double type. And user also can store the decimal point in those variable. And then we move to the next line, which is 120. User enter the constant number for row 2 in answer 2. And then we prompt user to enter the number for row 3, column 1, column 2, and column 3 in G, H, and I respectively. And then we also prompt user to enter the constant number for row 3 in answer 3. And then the next part is we display the output in linear equation form. And then we put %.1f because we want to display the number in one decimal point. And it goes the same for augmented matrix. But the difference is we have the line here because it's in matrix form. And then we move to the calculation. So for the row 1, column 1, if it's not equal to 1, this is the calculation. B equals to B over A, and then it goes the same for C, answer 1, and A. And then we display the output after we calculate the number. We display the whole matrix. And then we move to the row 2. So for the row 2, because if it's not equal to 0, and then we need to do the calculation like this, E equals to E minus D multiple B. And equals the same for F, answer 2, and D. And after we'll calculate for the row 2, we display the whole matrix. And then we move to the row 3. If it's not equal to 0, this is the calculation. H equal to H minus G multiple B, and then it goes the same for I, answer 3, and G. And then we also display the whole matrix after we calculate for the row 3.
Now I will explain for column 2. Calculation for row 2, column 2. If E is not equal to 1, normalize the elements in the second row by dividing them by the value of E. Next, you will update the matrix and output the result. Calculation for row 3, column 2. If H is not equal to 0, eliminate the variables in the third row by subtracting a multiple of the second row from it. Next, we will update the matrix and output of the result for row 3 and column 2. Next, calculation for row 1, column 2. If B is not equal to 1, eliminate the variable in the first row by subtracting a multiple of the second row from it. Now I will explain for column 3. Calculation for row 3, column 3. If I is not equal to 1, normalize the elements in the third row by dividing them by the value of I. Calculation for row 2, column 3. If F is not equal to 1, eliminate the variables in the second row by subtracting a multiple of the third row from it. Last for calculation for row 1, column 3. If C is not equal to 0, eliminate the variables in the first row by subtracting a multiple of the third row from it. Next, you will update the matrix and output the result for row 1 and column 3. Last of the coding, it will output the final answer. Display the modified 3x3 matrix after all the calculation steps. Output the solution for variables x, y, and z based on the final matrix. It's providing a comprehensive solution for the system of linear equations.